use like a test pin, right? Red probe on a ground. Okay, got that. Now first black probe here on this point anode line, red probe on a ground. If you get, suppose there is a value around 500, that means this line is connected to the IC. Now turn the probes, red probe on a this point and black probe on a ground. Now again, if you get a similar value like 300 to 700, that means this line had a short or leakage. If you did not get any value on a forward bias, that means red probe on a this point, anode point, and black probe on a ground. Two type of bias, a forward bias or reverse bias, right? If you did not get any value on a forward bias like OL, or you can say 1000 plus also, if you get the 1000 plus value on a reverse bias, same, you get 500. That means this line connected properly. Okay, that doesn't mean there is a other problem on this circuit. Right now, for this testing, you can say this line is okay. Now, third scenario, if you did not get any value on a forward bias, on a reverse bias, you will see OL, right? Basically, I will tell you. Hello everyone, how are you all? Welcome back to the Phone Schematic Education in another new video. I hope all are you good. Today, I'm not look good, but I want to make a video for you guys. So I thought make a video first, because this is not a fashion related channel. This is an education channel. So it doesn't matter how do I look, because my job is giving you information or knowledge or education. So education is my priority, because this is an education channel. So I make a video on education. So it doesn't matter how do I look, right? Now back to the topic. Many people were demanding or commenting in videos, make a video on a graphics and light section. So today we discuss about the light section, how the light section work, how the light IC working, how to diagnose or troubleshoot the light if there is no light, step by step, with the schematic, with the diagram, so you can understand in a better way how the light IC pins detail each and everything in this video. Now first, how do you know if a phone come to you, there is a light issue or graphic issue? So suppose a phone come to you with a blank display. It's working well, but there is a no display. When you connect a charger, you heard the connecting sound. When someone called to this phone, it's ringing, vibrating, but there is a no display, a blank display. You also replace with a new panel or new LCD display, but fault remains same. But when you look at that carefully, you will see some flaunted graphics. Now you look at the help of with the torchlight or some flashlight, you will see the graphics. That means this phone working perfectly, but there is a light issue, light circuit not working properly. So how to diagnose this phone step by step? Now first thing, if you see the graphics, then this phone has a LCD panel, because there is a two type of display. First LCD we call IPS LCD display. Second AMOLED, you can also call OLED and Super AMOLED, right? Now if a light section fault in a AMOLED display phone, a premium quality phone, right, you did not see the graphics, there is a blank display. If you see the graphics, it must be a LCD panel on this phone. Both are different circuit. So in this video we talk about only a LCD panel, or you can say a basic light section. How to work a AMOLED light or graphic section we talk in another video, right? Now When you open the panel, there is a strip where the light bulbs installed in a series. There is a 6 to 8 bulbs. For glowing, this strip must be a need 20 volt to 40 volt. In your phone, you get only a 3.7 to 4.2 volt maximum. So how the light IC convert a normal voltage, or suppose 4 volt to 20 volt to 40 volt, 5 times or 10 times more. How the boost line working, all the information I will give you in this video, all the details. Before going to the light section, first we understand how many type of light IC. Second, how to identify where is the light IC in your motherboard if you do not have any diagram, right? So how do you know where is the light IC installed in the motherboard? Let's see first. After I will explain to you in a schematic, also animated diagram through the light section work. Now let's see how many type of the light IC, right? In front of your screen there is a picture, right? I will tell you one by one. Now first you have a 6 leg light IC. This IC is a pin IC. It has 6 legs, right? This is a common IC. You will find it in 3G phones, 4G phones till now, right? After that, this IC introduced a 9-ball light, 9-ball BGA IC. This IC is a glass IC, a small little tiny. After that, a 12-ball IC. How this IC work, each and every pin detail we discuss in this video about this IC, a 12-ball. Now, apart from these IC, some DC to DC converter like PMI 8940, this IC had installed a light section. Clear? Also, some DC to DC converter has graphic IC installed. Clear? Now in latest phones, you will see a IC with 24 volts, a glass IC, a little glass IC, right? In this IC, you will get a graphics section, also a light section. Clear? Now, after that, next, how to identify the light IC. Now, next, how to identify the light IC, right? If there is a no diagram, for schematics, you have only a motherboard. So how to recognize or identify the location of this IC? For this, a simple trick, or you can say simple way, just find the big coil along with the diode in front of you. In this motherboard, you will see a big coil along with the diode. Also, you will find near a 6 leg IC. In some cases, you will find a small little tiny glass IC, 9-ball or 12-ball, right? But there must be 2 components, a big inductor, also a diode, and they both connecting each other. How to identify? Diode, anode, one probe multimeter on a continuity mode, one probe diode anode, and other probe on a coil, right? You will see the beep. Any point of this coil, you will see the beep sound or 0, 0. That means these both are connecting each other. Remember, the multimeter probe on a anode, diode anode side. This side is, when you look at this line, this is the cathode side, right? So through this trick or this way you can find in any motherboard the light IC. I will show you some other motherboard. Now in this motherboard you will see this is a LCD light IC, also a boost coil. This inductor we call boost coil, also a diode together along with this IC. This IC also had a 6-leg IC. You will see legs. In some ones you get BGAs, ball IC. I will show you. Right, in another motherboard. Now in this motherboard we get a DC to DC converter or your charging IC 8940. I'm already just tell you in this charging IC you had already a light section installed. For this there is a 2 component near a big coil. You will see there is also a big coil, but there is a no diode. Now here it is a diode and the connecting each other, right? That means this is our light IC. Clear? Now it's a simple trick how to identify the light IC. Now let's go to the Borneo schematics and how this IC 12 ball light IC working, each and everything with detail. I will show you. Now let's see in the schematics how the light IC working, each and every pin detail. So first in Borneo, right, I'm opening POCO M2 schematics and layout, also the component name section. For this, first open the layout and just copy this, just copy display connector. In near display connector, most of the time you will see some couplers, right? A coupler resistance like this. I will show you in what about. These resistors for the data pins. Graphic data pins directly connect to the CPU. I will tell you all the details about these pins in a graphics section. Right now we will talk about only light section. Now for the light section, how you will find the light IC? Where is the light IC? For this, just open the layout and copy this connector, display connector, where the display connect, right? So paste in schematic. Now zoom. Now in front of you, this is a display connector, right? You will see 40 pins, 40 pin display connector. There is some pins else 43 pin, but there is these pins are ground. So basically you have 40 pin display connector. These pins belongs for LCM, data 3 negative, data 3 positive, data 2 negative, data 2 positive. I'm already just told you these are coupler data pins. We call MIPI lines, directly connect to the CPU for the graphic, right? Now you will see there is a VSN and a VSP. All these 1.8, these pins for the voltage requirement for the graphics. Also, when you zoom it, you will see a TP, INT, TP test, SPI clock, SPI MISO, MOSI. So these are the protocols for the touch. So in this section, in this connector, you will see basically 3 sections: a graphics section, a light section, also a touch section. Where is the light pins? Now LED A denote anode, means this is a LED for the light. A denote means anode. LED bulb, when you open your LCD, there is a strip. I'm already told you, each and every strip 6 to 8 bulb. This LED also has a type of diode, I'm already told you in a previous videos, in video MOSFET, transistor and diode, the full detail about the diode, what is diode and how to identify each and everything. So diode has two terminal, anode and cathode. So basically this LED anode means positive line. 18 pin and 17 pin cathode, K1, K2 are negative pin. So when circle complete, your LED bulb glow and your display will show light on a graphic time, right? So how this light working, I will show you. First, follow these lines. In this line you will see some filter capacitor, also a 0 ohm resistance, all three of lines. Why this resistance? For the protection of this line. Why this resistance is tall, I will explain to you in this video, right? Just first you will see this name LCD, BL, LED anode. The full form LCD, your display screen, right? And BL means backlight, LED anode, backlight LED cathode. Clear? All three of lines you had 0 ohm resistance for the protection. Whenever this line short to the ground, because this is high voltage line, in this line you will get 15 volt to 42 volt, depend on the circuit. When your phone or water logging or this line was short, this resistance open itself, right, and save the other side of the circuit, right? I hope you get my point. Copy any one of these lines, right? Just let's copy this by double click it. LCD, backlight, anode. And next, now this line goes to the AIC. Which IC is this? LCM backlight LED driver. That means this is our light IC. So through this pin, any one of these pins, cathode or anode, when you follow this line directly goes to your backlight IC, light driver IC. Clear? Now this IC is a 12-ball IC. You will see A series, A1, A2, A3. Where is A4? No. There is no A4. Now B1, B2, B3, B1, B3, C1 or C3, D1 and D3. That means this IC had A1, B1, A series, B series, C and D. A1, 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 A2, A3 and similarly B1, B2, B3 and C1, C2, C3, D1, D2, D3. That means this IC had 12 balls, 12 pins. It's a BGA IC. So how this IC work, each and every pin detail, how this IC switching and boost the voltage, right? I will explain to you. First we understood how this IC work. For every IC working, first the requirement of fulfill, I will explain to you. Now suppose this is our light IC. So every IC need for working are requirements, right? First a voltage requirement. Suppose let's say VPH, a main voltage, a main supply, voltage requirement of this IC. The other requirement of this IC is a controlling section, also the enable. This IC need VPH voltage to run, a basic voltage requirement for controlling when this IC work or does not work. So it's handled by a processor, your CPU, a master IC, right? After every requirement fulfill this IC produce output. Clear? If this IC only get a VPH, this IC does not work. Some people comment me, if any IC had a 1 voltage, why this IC does not work? If IC had already a voltage on the points, why this IC does not work? Suppose in this case, let's for example, VPH is always voltage. This light IC produce a output according only to the VPH, right? The light glow. Okay, but whenever your phone in a sleep mode, when your phone does not work any work, suppose in a night, in a daytime, on a working time, right? Whenever you do not touch your phone still on, but it's on a sleep mode. But VPH voltage is always there. Suppose this IC working behalf of only a VPH, the light is always on. That's why controlling section or enable is important. Which time this IC work or not work, it's controlled by your CPU. When consumer, or you can say when phone holder need light, after the CPU control this IC and emerge the light, or you can say activate this IC. When there is no need for the battery saving, also the other reasons, phone on sleep mode, like CPU deactivate this IC, but your phone still on. I hope you get my point. Now back to the schematic to understand how this IC works. So every IC need two basic requirements: a voltage section, a input requirement, and the controlling section. Get that? So first we see a voltage requirement. So you will see a in, that means this is the input line. In some IC you will say VIN, voltage input. Now follow this line. Now this line come from V system, because this phone had a MediaTek MTK, right? So V system. If there is a Qualcomm, you will see a VPH. Clear? Now with a 0 ohm resistance for the protection and some filter caps on this line, the line come from the V system line, and this line connected to the B3 pin on the light IC, right? Also a same line, again in this line you will see a coil. I'm already told you in identification section there is a coil called boost coil installed in this line. The other side of this line get back to the pin number D3, again goes to the this IC, a D3 pin. This pin called switching, for switching purpose, to boost the voltage. In Samsung and also some phones you will see LX, right? Now after this, in this line you had also a diode, right? Now some filter caps. Now copy this line and next. Now this line goes back to our display connector where we started a 0 ohm resistance, right? So next, now get back to the IC. First, we will draw these lines and I will explain to you again. So better understand. Now in front of you there is a diagram. Now there is a DC to DC IC, RPMI, right? CPU in a green color, display connector, yellow, gold and black lines, right? So this is our light IC. In your motherboard, this is a little tiny IC, but in this page, or you can see in this diagram, I will draw a bigger IC because there is a lot of lines, basically 12 lines. So we will introduce you each and every line, or you can say I will give you information of each and every line with the detail and with the animation. So that's why I will draw this IC, a big size, so you can easily understand how this IC works, each and every pin. From V system line, a line come to the pin number V3, right? So in this line you will get 3.7 to 4.2 volt. You will get in this line 3.7 to 4.2 volt, because on a VPH line you will get 3.7 to 4.2 volt. After, in this line you will see a buck coil. Also, the other side of the buck coil connecting to the same IC, pin number D3. So this line connected both sides. In between you will see a coil, a boost coil. Now in this line you will get a diode. I will show you in a schematic also. Now this line goes to the display connector, LCD backlight, anode. When your phone does not turn on, in this line you will get same voltage, 3.7 to 4.2 voltage. After everything okay, when your phone turn on, everything okay, this IC work, this IC, this line generate, convert 15 volt to 42 volt. How? I will tell you. First, you will see this line, how this line connecting to the display and light IC. If this line is open, there is no light. I will tell you each and everything. Now for the light, right, you need two terminal or two sides. Now this sides as a positive we call anode. Without negative, positive itself is a waste, or you can say useless. So for activate the LED or glowing the light bulb, we need cathode also, a negative line. So just clear this, right? Now first get back to the schematic. Now you will understood this line. I will tell you about cathode. Before cathode, I will tell you some other line. For this, we go to the schematic again. Now, you will see in this line, after the diode, another line come out from this line and goes back to the same IC called D2 pin, OVP, for the over voltage protection. This line basically a feedback line to sense the voltage on this line, right? This IC sense a feedback. So let's draw this first. After this, a line come out from this line and goes back to the pin number D2 called OVP, over voltage protection, or this line basically a feedback line, a sense line. If anything is wrong on this side short, suppose for the water logging, anything on short this line, through this line this IC shut down automatically, because this is a high voltage lines. So through this line, sense if everything is okay. Now let's get back to the schematic again. Now pin number B3 and D3 and D2 clear. Now pin number B1 and C1, HL, LED1 and LED2. Pin name LCD backlight LED cathode 1, cathode 2. When you click this line goes to the display connector with a 0 ohm resistance. Clear? Let's draw this. Now I'm already told you for the positive, a negative line is important. Without negative or positive itself are useless, right? For the light bulb, negative is important. Now you will see from B1 and C1, two lines come out and goes to the connector. These black color lines called cathode lines, right? So positive is there, negative is there. Also a voltage is there, 3.7 volt. So why the light not glow on your display, on your screen? Also another question arises. There is two questions. The when voltage come to your connector, you get a 3.7 volt here. Suppose 4 volt here. Also the negative line. The circuit is almost complete. So why this IC does not work or your light not glow on your display? Why your display blank? I will tell you another question. Why the cathode is 2 lines? In some phones you will see 3 lines. Anode only 1 line. This anode, a positive line. You must notice that most of the phones you see 2 or 3 cathode, but there is only 1 anode. For 1 line positive and 2 line negative. Why? If anyone knows why this circuit has created this 2 cathode or 3 cathode or 1 anode, only 1 anode. Why? Tell me in the comments. If you don't know, if you want to know, then also a comment. I will tell you why there is a 2 cathode or 2 negative lines or 3 negative lines, only 1 positive line to boost the voltage. Now get back to the first question. When the voltage is here, negative point is here, circle is complete voltage. Why does not a light appear in your phone or display light? I will tell you. Suppose this is your light LED bulb. Is screen a diode? This bulb working on a, let's say, 4 volt from below this bulb, right? This is a positive and a negative. When you connect in a series 6 or 8 bulbs in a strip for more lights to glow fully. Now if there is a 4 volt and 6 bulbs, that means 4 into 6, 24 volt need. If there is 8 bulb, then it's 32 volt need. But on the battery side, you will get maximum on a VPH or V system line, you get 4 volt. So how this light work? For this, we need maximum voltage. That's why in this line, when everything okay, you will get 15 volt to 42 or 45 volt according to the circuit of your phone, right? Now this happen after the switching. How the switching working? How this 4 volt convert to the boost voltage from 15 volt to just like 42 volt. or in this case you can say 24 volt or 32 watt, or 4 volt converted to 24 volt or 32 volt. How? I will tell you. Now you will see in this point 2 points. There is a ground also. This IC is a microcontroller IC. On this line, a switching line, right? This microcontroller connect ground, or you can say like a switching with ground in a microseconds in many times, right? So there is a magnetic field generate around the coil. So there is a high voltage like AC wave shape. After this voltage, when you will see high voltage on this line, right? The help of coil and diode, also a capacitors, filter this voltage and give it to the display connector on your display strip. After you connect the display, and this line goes to your LED strip, and your LED bulb glow. Your light will be turned on your display, right? I will able to tell you this much only on this video. There is a lot of more detail how the switching work properly in deep detail. If you want, then comment this video. I will give you a proper detail. Also, you will see this switching here with the DSO, not by the multimeter. A switching, right, with the DSO. So now you will see the positive line or negative line, how this IC work or switching or convert or 4 volt to boost voltage, convert to boost voltage, like 15 watt to 42 watt. Clear? Now after this, another line need. Your display turn on, suppose, but sometime you need a less brightness, sometime you need more brightness. So controlling the brightness, you need one more line. This line called CABC, also PWM, pulse width modulation. I will tell you. Just clear this thing. Now through pin number A1, the line generate and goes to the connector. Same pin from the display connector, a line from the display IC. In display strip, you will see IC. This line connected to the another IC, right? After this IC had controlled the display, basically brightness. You will see a brightness icon. You can easily lesser or more bright your display with your touch, or you can say with one click through this pin. In this pin you will get 1.8 voltage, right? If this pin damage, your phone display is blank. If negative pin damage, your phone display is blank. If is this pin voltage line damage, your phone display is blank. Now before going to the requirement of this IC, the controlling panel, how this section work, right? I will tell you. Suppose a phone come to you for the waterlogging reason or any reason, there is a no display. I mean to say a blank display. When you know your phone is turning on, either connect your charger or turning on or check your ampere meter or from vibrate or bell, any method, you know your phone is on. Still there is a blank display. But when you focus or help with the torch or any flashlight, you will see some graphics or fainted graphics. That means there is a graphics. There is a LCD panel, not AMOLED, OLED. super AMOLED display or AMOLED display or OLED display, if your light and graphic any had a problem, your display totally blank. But on the LCD section, 90% in phones, if your light section is damaged for any reason, for water damage or water logging or shorting or open any line, you will see the graphics when you see the carefully with the help of torch or fainted graphic. But 10% even LCD phones does not have the graphic. So I have also a trick through one click, or you can say a shortcut trick through you can verify whether the problem in your light IC or your light section or your graphics section. I will tell you later. Now you must have understood what these three lines work. CABC as a brightness controller, a negative line for a negative, and anode is a positive, cathode is a negative, and anode is a positive. How these three lines work, right? Or connecting to the IC. Now, how to check one by one, I will tell you. If we talk about the cathode line first, suppose this black color line, basically cathode, we call a negative line, right? Then it is a negative line, clear? In this line, there is no voltage because this is a negative line, right? So it's rare you will see through this line at a problem in a light section. You will see a rare this line damage, except if this line has not connected properly, or you can say dry soldered with water logging or rust with carbon, or somehow open from anywhere. There is a zero resistance. Sometimes this resistance is missing when you open the shield, or if a phone come to you, suppose already somebody working on it and somebody remove the cane, or you can say shield or cover on it, a steel cover, somehow this component are missing or not connected or loose from both ends. How, right? So this line had a problem. Now, if you had a diode value on a diode meter, when you meter on a diode mode, if you get a diode value, suppose 600 on same both side, both lines, that means this line connected properly with the IC, or in some cases this line got a beep on a diode mode. If you have multimeter, you use a multimeter or yellow multimeter. So you will see rare in this line had a problem. Just you can check, or you can say you can measure if this line is connected or not connected. That's it for the cathode. Clear? Now the biggest problem that comes in the light section, where you see there is no light, or damage anode line, or this line, anode line. 99% you will see problem through this line. So whenever water comes contact into the display connector, right, or you can say a light section in a water logging, somehow the water contacts the light IC or light circuit or display connector. This line is short or open because this is a heavy voltage line. On this line you get 15 volt to 40 volt approximately. So whenever water contacts in this line had open or short. Clear? Also, you must have noticed that many times the connector pin where the anode line connect from this side, right, where the anode connect, this side of the connector is burned on these points, anode points. Basically reason because this is a high voltage line. That's why it is. I hope you get my point, what I taught you. Now, how to do we check anode line step by step? How to measure in entire mode? Now, there is a two type of testing. First, cold testing. CUL, CWL, cold testing. In this type of testing, we test with the diode mode, multimeter on diode mode, right? With no connected power source. I mean to say no charger or no battery. Testing only on motherboard, multimeter on diode mode. Preference on a reverse bias. Right? Now what is reverse bias? I'm already told you in the previous videos. Now the other testing method is cold testing. After the cool testing, we can check hot testing. Right? In hot testing, multimeter on DC voltage mode. We can check in a hot testing our voltage lines. Or you can say measure the voltages. So first, we apply a cold test, a diode mode value. Second step, testing with the DC mode value, or you can say hot testing. In this testing, hot testing, we connect the power source. Right? Clear? Get it? Now, on a cold testing, it means a diode mode value, multimeter on a diode mode. On a reverse bias, what is reverse bias? Black probe as like a test pin, use like a test pin, right? Red probe on a ground. Okay, got that? Now first, black probe here on this point, anode line, red probe on a ground, right? If you get, suppose there is a value around 500, that means this line is connected to the IC. Now turn the probes, red probe on a this point, right, and black probe on a ground. Now again, if you get a similar value like 300 to 700, that means this line had a short or leakage. If you did not get any value on a forward bias, that means red probe on a this point, anode point, and black probe on a ground. Two type of bias, a forward bias or reverse bias, right? If you did not get any value on a forward bias, like OL, or you can say 1000 plus also, if you get the 1000 plus value. On a reverse bias, same, you get 500. That means this line connected properly. Okay, that doesn't mean there is a other problem on this circuit. Right now, for this testing, you can say this line is okay. Right? Now, third scenario, if you did not get any value on a forward bias, on a reverse bias, you will see OL. Right? Basically, I will tell you again. First, clear this thing. There are three type of scenario in entire mode testing or cold testing. First, you get on a reverse bias, suppose a value 500 value, right? And when you reverse the probes, when you turn the reverse the probe, black on a ground and red with the testing, you get nothing or 1000 plus reading. That means it's a OK sign from here now. That doesn't mean there is a no problem on a circuit. Now, second, if you get a value of 500 on a reverse bias, on a forward bias, when you turn your props, right, you get 300 to 700. That means in this line, you will find a short or leakage. Right? The second scenario. The third scenario, you did not get any value. I mean to say OL on a forward bias, also a reverse bias. That means there is a no connectivity. Right? It means this line had open. First, apply these steps to confirm where is the fault. Now we discuss one by one. Right? Starting from here, OL. After shorting, after OK. How to confirm, or you can say through this line, how to confirm these three steps in a detail. Right? Now there is a circuit. First, if you multimeter on a diode mode on a reverse bias, right, you did not get value here. Suppose OL. Right? Now there is you will see in a schematic, there is a resistance, a 0 ohm resistance. Now check the other side of the resistance on a diode mode. If you get a value, suppose 600, that means this resistance is open. Why? When the water comes contact this connector, from the shorting or high voltage, chances this resistance open itself. So there is a no connectivity between the circuit, or you can say IC, and the connector. So what you do? So just take a jumper from here, not here, to anode line, this connector. Most probably your job is done. Your phone have been repaired. Light will come back to your display when you turn on your phone. This is a shortcut method. You can do these things also. Suppose this line, I'm talking about, just a second. I'm talking about this line. In this line you had a resistance, right? If this resistance is open, you can measure here 600 value. On this side, you will get nothing. You can connect a jumper from both ends. After you can measure on the connector, if you get a value here, that means your job is done. Your first step is complete. Most probably chances your earphone have been repaired. Now, in some cases, when you connect a jumper from here to here, from this end to this end, but when you measure the diode mode value, there is still open. OL. Why this happened? Because when the water logging or contact to the connector or this line, a voltage line. This line burnt, or you can say melt internally with the layers, right? That's why this resistance is also open. Sometimes you will see the other end of the resistance is also damaged, or there is a no print, right? That's why I'm says take a jumper from this side to connector. This is a shortcut method. If you apply this, you will do this thing first. After you can take a jumper. After masking with the UV tube for the security, because this is a heavy voltage line. If this jumper contact any other pin, because if everything is okay in this line, you will get approximately 25 volt, sometimes or 40 volt. So suppose there is a 1.8 line or 1.8 connector somewhere in this near about. Somehow this jumper disconnected or connected here on this component. This whole circuit will burn. If this line come from the CPU or connected to the CPU power IC, the circuit will burn internally. I hope you get my point. Clear? Is clear to you? How do you check first step? Now the second step. Same process on a reverse bias. We red probe on a ground with the black. When you check here, you get 600. When you turn your probes, there is still suppose 400 or 500 or 700. That means this line is short. Clear? Or leakage. Clear? So how to repair this line? From the connector side. First I'm talking about the connector, not the circuit. Step by step we talk about this line. I'm discussing in a deep level, so you can check each and every step. I'm giving you each and every detail. If you get both sides parallelly, reverse side also forward side, that means this line has a short. So what to do? Say on this line, anode line, you get a resistance, a 0 ohm resistance. Right? First you remove this resistance. Now some people say is, why remove this resistance? You can inject the voltage directly on the connector, on the anode line, or this side, on the resistance. You will find the shorting, which component and short. A Rosin method. I'm already tell you how to remove any type of shorting, minor to minor, in a previous video. You can, if you don't know how to remove shorting, right, you can just go and watch the previous video, this video. So getting back to the topic, some people say, why to remove this resistance? Because most of the time in this circuit there is a one cap. Also in some time there is a no component installed. Only a resistance after this line directly connected to the display connector. Clear? So why you remove this component or resistance? Directly inject a voltage and you will find a short component, right, where the short is. I'm agree with you, on 90% chances you will find the fault, but on a 10% chances, no component will be spot or melt if you apply a Rosen method. Also, even you replace your IC, diode, so even you replace most of the components like capacitors, the problem still remains. Why? That's why I'm telling you step by step, checking with the step by step. Now, first, I'm again on this line, you had a resistance. I'm sharing with you my practical knowledge, right? Because this case on my table in few days back, I'm applying all my tricks, but the short still on the board on an Anode line. So just remove this resistance. Now measure where the short is, which side. On this side, there is a IC circuit. Suppose this line connected to the circuit called diode, each and everything, and this side had a connector, right? Now when you open the resistance, you will find the short, where the short is, which line had shorted, from the connector side or the IC side. If the short is on IC side, you can apply injector voltage on this side. Clear? Now suppose short is on this side, a connector side. Now there is no component. Suppose even a one cap, like in this model, had a one capacitor in between them, right? This capacitor. You can also remove this capacitor, but there is a still short. When you measure on a display connector, there is a still short. So how you can find the short? So I will tell you, sometimes shorted internally, the layers internally shorting, or you can say connected each. Now let me explain to you in a schematics so you can better understand. For this, go to the Borneo, right? Now first get back to the connector. Now in this anode pin. Now first check this anode pin, right, on a reverse bias with the multimeter on a diode mode. Let me show you. Black probe on this pin, black probe on a 20 number pin, and that probe on a ground, right? Suppose you get 500 to 600 diode value. Now reverse the probe, then probe on a anode line, and black probe on a ground. This is called forward bias. Now you will get similar, like 300 to 700 diode value on a forward bias, right? Now this is called reverse bias. That means you confirm there is something short here or leakage, right? Clear? First thing, remove this resistance. When you remove this resistance, both ends are open, on this side and on this side. Clear? Right? Now check one by one on entire mode on a reverse bias. Suppose this side is okay and shorting in this side. In this side, you can only see a one capacitor here. You can also remove this capacitor. Sometimes you will see there is no capacitor or any component in this line without a resistor. After resistance, you can see a filter caps, but on a display connector and this resistance between, there is no capacitor or any component in a parallel line. So how this line is short, because if you measure and you confirm that this line has a short and a diode value on this point, confirm. If you do not remove this resistance, if this line, only this line had short, and you do not remove this resistance, you can apply Rosen method on light circuit near the light IC. Also the capacitors, filter caps on this area, and you can inject voltage here like 4 volt and 5 amp. There is no shorting on this circuit. Clear? I will explain to you in a motherboard so you can better understand. Suppose this is a light circuit, a light IC, a coil, a capacitors. If you apply a rosin here, a rosin smoke here on it, and you inject on a display connector 4 volt, 5 amp maximum, right? You will see there is no component or any IC get heated or melt, because shorting between, just clear this thing, because shorting, like this is the connector and this is our resistance, and this line connected to the IC, right? This line IC. Shorting is here on this line, right? You get inject voltage on this area. So how this area get heat up? The question comes, how this line is shorted if there is no component installed in between this display connector and this resistance? If there is only a one cap, you already remove this capacitor. Sometimes you did not see any capacitor in other circuits. So how this line shorted? So I'm telling you, your motherboard had 6 to 7 layers, made with 6 to 7 layers. So this is our main positive rail. After you will see ground, positive, ground. So this line is a high voltage line. Sometimes when this line short, it's getting heat because there is a very thin line. This high voltage line, this anode line, is a very thin line. Sometimes it's connected the ground. So you can see when you measure on a diode mode, here you will see there is a short. I'm already faced this type of problem. So how can you repair if you had this type of fault? Even you can replace your diode, your coil, your whole charging circuit. You did not find any shorting, you replace whole the circuit, but there is a still shorting. How can you repair? That's why I'm telling you with my experience, open this resistance so you can confirm where is the shorting. Now if shorting is this line, just remove this resistance from this end. The both ends are open. From this end connected to the IC, if you get measure a diode value here, you will see there is a good diode value, like 500. Now what is the next step of your? I want to tell you, first I'm remove this. Now focus on this connector, just a second, like this connector. These pins, connector pins, right? Now these connector pins connected internally this pad on a motherboard pad, right? Here solder with this pad. Now one thing, First, disconnect these 2 points. Suppose this is an anode line. Disconnect these connector pin and through pad. After this pad, or you can say print on a motherboard, cover this print with a UV masking. Right? After this, you can check on this point. You will get OL, no value here. Understood? Now, this line still shorted. This is the resistance place where you open the resistance. If you measure this line here, you get a shorted, right? But this side is completely okay. So take a jumper from this side and put it on here, solder on this side, because you already mask this print, right? So a good diode value go to the connector. Now after, you can turn on your phone. Most probably 70 to 80% your job is done, right? If there is no problem on other side, this IC side, 70 to 80% your job done. Your light coming back, right? Your fault resolved. Now go to the third scenario. In third scenario, you get a good diode value on a connector, right? On a reverse bias. When you check on a forward bias, there is a no value or 1000 plus. That means this anode line is completely okay. Now after this, your first step is complete. Your display connector side diode value is okay. If the fault still remains, you can confirm the fault in IC side. Any component is not okay, maybe this light IC or any capacitor. We will find it in a hot testing. How? The next step, we apply a hot testing, so you can confirm where the problem is it. Now after the cold testing, when you confirm everything is okay on this connector side, now let's move on to the but fault still remains. There is no light on your display. So next step, we can check our hot testing, right? We can measure with the hot testing. Now in a hot testing, we test, or you can say we measure voltages. Clear? So multimeter on a DC mode. Now DC voltage. Now we check in a forward bias with a red probe, black probe on a ground. So check this line first, anode line. Most probably after the cool testing, you clear this line, you get a 3.7 to 4 volt if fault remains same. If you get this value, a V system value, or you can say a battery value here, when you connect your battery or charger or turn on your phone, you get a value here. That means this whole line from IC to connector, anode line is completely okay. This whole line. That doesn't mean this light circuit is okay. If you get here value 3.7 to 4 volt, that confirms this line connected properly, because you will see this value on the connector. Maybe a problem in a switching side, right? Maybe a problem in a diode, maybe a problem in a coil, maybe a problem this IC could not switching properly, maybe no connectivity between this D3 pin and this coil, because you can see the reading a diode value or a V system line. Maybe you will be confused, right? Maybe a problem in a CABC line, maybe a problem in a controlling section of this IC. So how to find these problems? We take next step. Now from here you confirm this line connected. Now next step, check this line, a green CABC line. For this we will go to the schematic and we will see how to check this line or measure this line. For this, Borneo in schematics. Now 11 number pin or CABC. Follow this line. CABC means cathode anode backlight control. Through this line you can control the brightness. Remember, I'm already just told you in this video. In this line you will get first capacitor, but there is a call written on NC, not connected, so there is a no capacitor. Now LCD, CABC. LCD, your screen, CABC, cathode anode backlight control. Through this line you can control your brightness, lesser or more, according to your satisfaction, according to your eyes. Now double click it and next. Now this line goes to the light IC, LCD backlight driver. This line also attached with the display PWM. Now this line comes from the, or you can say connected to the CPU for sensing. In this line you will get a signal, a digital signal. Now this line connected to the A1 pin. Also another line connected called DSP, display PWM. Now this line goes to the CPU. In this you will see a 0 ohm resistance for sense this line, right? In this line you will get 1.8. If you did not get 1.8 or this line is short, right, your LCD is blank. Confirm? Understood? Let me show you in a diagram. On this green color line, if this line open or short, or if you did not get 1.8 voltage on this line, pin number 11, you will see there is a no LCD or LCD blank. So remember this line. Also you will check this line. Now after you will get 1.8 voltage here. That means the fault is on light section. Maybe this coil is not boost the voltage. So that's why you get 3.7 to 4 volt here, right? Maybe this IC does not switching with coil. Maybe this diode had a problem. So most of the technician stuck here if they get a 3.7 voltage on an anode line. Also CABC is okay. Even they replace this IC with a new one. They replace a coil also. They replace a diode also. Everything replaced, but fault still remain same. There is no light. The mind does not work. So where is the fault? So I will tell you. Now sometime when water contacts this IC or any shorting, this D3 pin and this coil, connection lost. There is no connectivity. Now you get a diode value here. This diode value also belongs to the IC because this IC connected both sides from the coil for the switching. That's why. Now how to confirm these two pins connected each other or not? First, you can remove, or you can say lift up this IC, pick up this IC. After, you can measure with the connectivity between 2 points. Second, you can check with a trick, but I will not able to give you here right now. I'll give you in another video. So how to confirm where is the fault? This IC is faulty, this coil is faulty, or this diode. Also, sometimes the controlling section which connected from the CPU, right? This controlling section does not work, or any line is not connected to the IC or not communicate with properly. So this line had a problem. Now I will tell you about after this of controlling section. Pin number A2, right? This pin also connected to the CPU, called SDA, serial data, right? Pin number B2 called SCL, serial clock, and pin number A3 also connect with the CPU, called hardware enable. Now these two lines, SDA and SCL, is I2C communication line. Through these lines, CPU takes information how this IC work. These line connected with the 1.8 resistance, a pull-up resistance from power IC. Now this hardware enable line for the sleep mode activation. Now if this line had a problems, these three lines, a controlling section basically had a problem. How to solve? Our first thing, you can lift up the CPU, open the CPU and clean it and rebond it and fix it again, right? But there is a time consuming process, also with a risky. If your hand skill is not good enough, your CPU, if there is a less chance. For this, there is another trick. Without touching the CPU, you can repair these lines. Now the video is very long. That's why I could not tell you a lot of things, a lot of information that remains, like controlling panel and the other deep details, the deep methods, how to fix this light section in a few minutes. If you want to full detail, I will give you in another video. For this, if you want, just follow us, subscribe us, and share this video as much as possible with the other technicians, right? Now, if you watch this video till here, it means you want to learn seriously, or you want to learn seriously phone repairing with schematics or diagram knowledge in a proper way, like a pro. For this, in a starting of the video, I am already say that in last of the video, I am announcing something. I want suggestion from you. Now I'm announcing that, or you can say, for the learning purpose, who follow me truly, who like my teaching, right? Who want to learn from me, I enable the membership. I enable the membership on my YouTube channel, right? So you can suggest me a minimum, a comfortable price, right? You can tell me converting your currency in US dollar. So most of the people in this channel are from different countries. So if you convert your currency in US dollar and tell me the comfortable price, so everyone can understand this. Now when I will start a membership according your prices, right? Now what are the service available in this membership program? I'm not clearly create a roadmap about membership. That's why I'm not enabled yet. But there are still available services. I want to tell you in my mind. First, you get my WhatsApp number, right? So you had any doubt, any question in your mind, you can ask me on WhatsApp, right? Second, you get premium videos. How many videos? I'm not decided yet in a month. Third, a live conversation with members on a YouTube. Now fourth, suppose a phone come to you, right, for a repairing or any fault. I can give you a guidance on this with schematics and diagram detail, with proper steps detail. There is a lot of things like a personal one-on-one mentorship. So if you are a fresher or on a second level, on a third level, does not matter. One-on-one, you can ask me anything. I will guide you about tools, about schematic learning, about courses, anything. When I'm creating a proper roadmap, I will announce it. After, I will enable the membership. For this, if you have any suggestion for price and services, you can tell me in comment. Now this video is a very long video. This is it for this video. See you in the next video. If you like this video, if you think you learned something from me, share this video, subscribe this channel, share with your other technicians. Thank you so much. Love you all. Bye-bye.